Welcome to the next installment of this Unreal Engine tutorial series where we've been building a smart enemy AI system inspired by the Xenomorph AI for an alien isolation. So far in this series, we've covered most of the basics required for implementing state trees in Unreal Engine. In the upcoming videos in this series, we'll be moving into more advanced topics and implementations, as well as reverse engineering specific states and behaviors from the game Alien Isolation. In this video, we'll be giving our project more of an alien isolation feel by firstly adding in a pre-built gameplay environment that I've modified from the Lyra Project. This will provide a level for the alien to hunt the player and other NPCs. We'll also be changing our player character's perspective to first person, but I thought it might also be fun to transition between gameplay perspectives using the new Gmaeplay Camera Director plugin. Finally, we'll be adding in a custom mesh for our alien character and setting up its animation blueprint. All of the assets used in this video will be provided for free for you to download and are linked in the video description below. The project files for this lesson will also be provided for free download as well. So with the introduction out of the way, let's get started on today's lesson. Now the first thing that you're going to want to do is you're going to want to head to the Gumroad page linked in the video description where you'll find the Alien Assets project. You'll just need to download and unzip this folder and then go ahead and open up the project. Now this project was made in Unreal Engine version 5.4. However, you can open up the project in later versions such as 5.5 or 5.6. However, you won't be able to open this project in versions earlier than 5.4. If you absolutely did need access to these assets in earlier versions of the engine, you may need to use something like the Asset Downgrader plugin that you can find in the Fab Marketplace. Just keep in mind that this is a paid plugin. I have used it before, it does work, but I have not tested it with these assets, so just keep that in mind. So now let's go ahead and open up the project. Once your project is open, head down to the content drawer, and then we'll right-click the Alien Assets folder and select Migrate. And we're going to migrate all these assets into our main project. So you'll want to navigate to where you store your main project. And you want to select the content drawer of that project and then click Select Folder. Now this may take a few minutes to migrate all the assets. And once that's finished migrating, we can go ahead and close down this project and open up our main project. So now we have our main project open, but one thing I want to do is fix a bug. During the last video, we set up the look at animation for our alien character, but later in the video, I changed the character's rotation settings to use controller desired rotation. This was a mistake as it breaks our alien's look at animation. So, in the alien's character blueprint, under class defaults, search for rotation and deselect use controller desired rotation, then select orient rotation to movement. So now that's all working as it should. Now that we've opened up your main project, let's have a look at some of the assets that we've imported. So we'll go to the content drawer and we'll go up to the top content folder. And in the new Alien Assets folder, we will go first into maps and then open up the LVL station map. Now you won't see anything in the map at first, and that's because we're using world partition for this map and we haven't loaded in the assets. So what you'll need to do is you'll just need to open up the world partition window here. To find that, you can go to window and then select world partition and then make sure that world partition editor is enabled. And then all we need to do here is just drag a box over all the assets here and then right click and then select load region from selection. And that will load in all the details of our map. We'll just wait for everything to compile. You might notice a little progress bar down here, which is showing that it's preparing all the mesh cards for the assets. So now that that's all loaded in, let's take a look. So this is basically the Lyra map. And I've just changed a few things around, changed the lighting, and I thought that this might give us a good area to play with because it is somewhat reminiscent of the sci-fi space station. I have also extended the map a little more. So at the back here, there's an extra area that you can go through. And I've set up these little vent area locations where the alien will be escaping up into the vent. And these are just corridors and rooms that repeat a little bit just to give a bit of extra variety to our map. And I decided to leave some areas without lights so that we could implement a flashlight mechanic for our player character as well. So this will be the sandbox in which our player will be hunted by the alien. So this will give us a nice alien isolation feel to our game. So let's look at what else I've included in the assets folder. So if you go into the mesh, you'll notice this SKM_alien skeleton mesh. So this is a skeletal mesh that we'll be using for our alien, very reminiscent of the xenomorph design. Now this mesh was created using Meshy. It's an online AI generated mesh. Just something simple that we can use to continue prototyping with our project, but something that will give us a better feel for the alien character. Now, in addition to the actual mesh, I've also included a number of animations as well. So if we go into our anims folder, there are a number of animations that I've adapted from pre-existing animations from places like the Game Animation Sample Project and also the Advanced Locomotion Project. And many of these animations I've modified by hand. Took a very long time and a lot of work to get through all this, but you'll see that we've got some really nice animations to work with here. So for example, let's have a look at Idle Break version 6. So this animation was modified from one of the Game Animation Sample Project animations and just gave it a bit more of a creative vibe. Apart from these idle break animations and idle loop, we've also got some locomotion animations as well. So we've got walking animations. So we've got 8 directional walking animations. We've also got 8 directional run animations as well. And we've also got some turn in place animations. Got 90 or 180 degree turns. And finally, we've also got this perform folder, which has some miscellaneous animations. So for example, when the alien has seen the player, and the alien has seen the player and is preparing to attack, and I've got some animations here that we'll be using for upper body montages. And finally, we've also got an animation for when the alien is going to jump into a vent. So let's go ahead and close that, and we'll delete the skeleton mesh from our map. So first things first, let's bring in a player start into this map. Go over to our place actors, go over to basic panel and drag in a player start into our map. And we'll also just go up to the world settings tab, then search for game mode. And under game mode override, we will select GM_alien. Go ahead and press play. We'll now get our character in the scene. But of course, in the game Alien Isolation, there is a first-person perspective. So let's go ahead and modify our player character into a first-person perspective view. Now, I mentioned at the start of this video that we're going to be using the new Gameplay Director camera plugin. So what you want to do is you want to go to your plugins and then search for Gameplay Cameras and make sure that Gameplay Cameras is enabled. This is an experimental plugin. So depending on when you're watching this lesson, there may be some changes to the workflow for this. If there are significant changes, I will add in an update video. So just check for any pinned comments below for any significant updates. So let's go down to our content drawer and we'll go up to content and then into shoot content. So in here, I'll create a new folder and we'll call this Camera Director. Open that up. Then we'll right click and we'll go down to gameplay. Now, there are a few different assets here. The ones we're going to be concerned about for now are the camera asset and the camera rig. Now, the difference between these two is that a camera asset is what will be added to the camera for our player, and the camera asset will handle switching between various camera rigs that we create. So first thing first, let's create a camera asset, and we will select Blueprint Camera Director, and I'll call this CA for camera asset underscore player camera. And let's open that up. Now, you won't find much in this camera asset. What this camera asset essentially does is it provides a way to transition between the different camera rigs that we create. And it does that by using a Camera Director Evaluator class. You'll notice that at the moment we have no Camera Director Evaluator assigned, and this is preventing the camera asset from building correctly. If we try to select build here, you notice that it says no evaluator blueprint class is set. And we also get a warning saying that camera isn't using any camera rigs. Let's go ahead and create an evaluator and a camera rig. So first things first, I will go over here and select the create new blueprint option. And this will create a Camera Director Evaluator class. So we'll go into our Camera Director folder, and I will just change this to CD Evaluator underscore player camera. Hit save, and this will open up a Camera Director Evaluator. So what the evaluator does is it handles the transitions between different camera rigs, which we can control in blueprints. But we haven't created any camera rigs yet, so let's go ahead and create one of those. We'll go to our content drawer, and in the same folder, we'll right click and go to gameplay and then select camera rig. We'll call this cam rig underscore first person. And we'll go ahead and open that up. And what we're presented with here is a graph to customize our player camera. It will always start with a root node, and there are a number of tools in our toolbox over here that we can add. For example, an autofocus node if we want to enable autofocus for the camera. There's also a boom arm if we want to add in a camera boom. And there's a lot of different options in our toolbox that we can select from. This is a very powerful plugin that Epic Games seem to be working on, and it's entirely possible that this will completely replace the previous way of utilizing cameras for gameplay. Let's go ahead and delete these two nodes that are created, and the first thing that we're going to add is a sequence node, which you can find at the very top. This will allow us to implement other nodes in sequence. Now, there actually is a pretty decent quick start guide available in the Epic Games documentation. It is a little bit out of date, as with many of the experimental plugins, things can change pretty dramatically between different versions. So there may be a few things in here that are a bit out of date, but all in all, there is some pretty good information here, and we'll go through some of this as we progress. Now, the way that they've set up this first-person camera rig isn't the way that I like to do it, but we'll go through how they've done it in this documentation first, and then I'll show you how we can change it slightly to get a better perspective. So the first thing we're going to add is a boom arm, and we will hook that up to the 0 sequence. And with the boom arm node selected, there are a number of different options in here that we can customize. For example, the boom offset, this will offset the location of the boom arm. And you can also expose these to blueprints as well. So if we create an interface parameter, we can expose this to blueprints. And when you create a parameter, it then appears in the parameters section over here. We're not going to worry about the parameters for now, so I'll just go ahead and delete that. And for the first person perspective, I will set a boom offset of 50, 0, and 50, 50 on the X, 0 on the Y, and 50 on the Z. So this means that it would be 50 units slightly forward of our character's position so that it's not clipping inside the character's mesh. And it will also offset 50 units upwards so that we're level with the character's head rather than being at the pelvis level. But we're not quite done with this yet because we still need a way for our player to be able to control the camera direction. And for that, we need something to input into our input slot here. What we will use, in this case, if we drag off this input slot and select Input Axis Binding 2D, then with this node selected, we will go over here to where it says Axis Actions and then click the Add Element. We want to select the Enhanced Input Action for looking with our mouse. So for this one in the game, I'm using the IA_mouse look. So I'll go ahead and select that. We'll leave the rest of these settings at default for now. We will need to change these, but we'll go through that in a moment. For now, we'll just also add in another node in our sequence here. If we go back to our toolbox, we'll add in a field of view node and just hook that up to the next index of the sequence. For our field of view, we'll kick this at 90 degrees for now. So basically what happens here is that when the game starts, it will set up our camera based on the sequence of nodes that we've programmed in here. So it will set up our boom arm to be in the correct position, as well as the input binding that will direct our boom arm, and it will also set the field of view of our camera. You can also add in post-processing effects if you like. There's a whole bunch of different options that you can experiment with. For now, we'll just build this and save. And now let's go back to our CD evaluator. And in the evaluator, we're provided with this event here, Event Run Camera Director. All we're going to do here is drag off the execution pin here and type in activate, and we want activate camera rig. And we will add the camera rig first person asset that we've created, compile and save. Now, if we go back to our camera asset, the CA_player camera, now that we've got our evaluator in here, we can go ahead and build, and we no longer have any errors, and we'll just go ahead and save. But now, how do we implement this camera asset? Well, to do that, we need to open up our player character. So we'll navigate to Blueprints, Characters, and we'll open up BP third person character. And because we're going to be using the new camera director system, we no longer need this code here to change the camera boom. So we'll go ahead and delete that. Go to our viewport. At the moment, we're using a follow camera, which is attached to the camera boom. We're going to delete both of these. So we'll select both of those and hit delete. And we'll just simply add a new component and type in gameplay and select gameplay camera. Then with that gameplay camera selected, we'll go over to our camera asset here and select our camera asset, compile and save. And there's only two things that we need to worry about here. We need to make sure that auto activate is checked. And we also need to make sure that auto activate for player is set to player 0. And then select compile and save. So let's go back to our level and hit play and see if this works. So you'll notice that it is working, but the rotation seems to be incorrect. So if we move the mouse up, the character looks down, whereas if we move the mouse down, the character looks up. You'll also notice that the pivot point is not really rotating at the correct position. It's sort of rotating at where the zero point of the camera boom is rather than the offset position that we set. So we'll fix the up-down movements first. So we'll escape out of this, go to our camera rig, and then select the input axis binding. And to fix this, we just need to select revert axis Y, build, and hit play. And now that issue is fixed. But there's also something else that we can do here. We don't want to be able to move our mouse 360 degrees because the character's head doesn't move that way. So we'll escape out of this. We'll go back to our camera rig. And what we're going to do is we're going to clamp the Y axis. So we enable clamp min and clamp max. We'll just set this to -90 on the minimum value and 90 on the maximum value. Build and compile. to build and save, and then we'll go back and press play. And now the axis will be clamped on the up and the down. But this still doesn't look all that good because the camera is not pivoting at the correct location. So we'll escape out of this and go back to our rig. Now this is how it's set up in the Epic Games documentation, but it doesn't really work very well. So I found that a better way of doing this is to go back to our boom arm and set all of this back to 0. So 0 on the X, Y, and the Z. And we'll add another child pin. And we will move these 2 pins down by holding the control key and dragging. And what we'll do here is we will add an offset node to our graph and then hook this up to the 0 index. And in this offset node, on the translation offset, we'll use those same values of 50 on the X, 0 on the Y, and 50 on the Z. And then when we compile and save and go back and press play, you'll notice a much better rotation here. It's pivoting at the correct point, and we can also see more of our character, but the character's animations aren't moving correctly just yet, but this is a better pivot point to start from. So now let's just fix our character's animations. So if we go back to our BP third person character, the best way to fix this is to select the root component here and then select class defaults and then search for rotation. And we want to uncheck orient rotation to movement and check use controller desired rotation. Compile and save. And you'll notice that it's still slightly off. And the way that I figured out how to fix this is if we escape out of that, if we go to our third person character, we can add a new component and type in gameplay, and we'll add a gameplay control rotation component. And then with the gameplay control rotation component selected in the details panel, we want to go to this activation section here and make sure that auto activate is enabled. And we also need to make sure that player 0 is selected for auto activate for player. And if we compile, and now if we go back and press play, you'll see that our mesh is turning to face the correct direction. We haven't added any turn in place animations for the time being, but this is fine for now. And now we've got a first person perspective moving as it should. But let's also add in a transition to a third person perspective as well. So if we go back to our camera assets folder, we'll add in a new camera rig. So we'll right click, select gameplay, and then add in a camera rig. And we'll call this cam rig underscore third person. And we'll open up that. First things first, we'll add in a sequence node and hook this up to the root. Now in the Epic Games documentation, they've also included the third person setup as well. So let's go ahead and set up that. First things first, we'll add in a boom arm and hook this up to the 0 index. Out of input slot, we'll drag out of there and add in an input axis binding 2D. Under axis actions, we will add an element and select our IA underscore mouse look. We will revert axis Y. We won't worry about clamping just yet. Wait to see the effect first. Select our boom arm and let's go for a Resident Evil style over the shoulder view. So for boom offset on the X-axis, we'll do -150. On the Y-axis, let's do 50. And on the Z-axis, let's do 70. Now let's add in a field of view node. Hook that up to index 1. Field of view will leave at 90. Now let's add in a dampen position node. So a dampen position node will make the mouse movements more smooth. So we'll add a new child pin and add this to index 2. So with the dampen position node selected, we've given 3 different factor options here. The forward damping factor, This will dampen or smooth the camera's movement in the forward direction. So when the character moves forward, lateral movement, so if the character is moving left or right of the camera view, and then there's the vertical damping, so if the character moves in the Z axis up or down, the camera will dampen the position in the Z axis as well. For now, let's just add in some values. If the value is 0, there'll be no dampening factor. Smaller values would dampen much slower, so a value of 5 will dampen much slower than a value of 25, for instance. Let's set the forward damping factor to 25. Lateral damping we'll set to 0, and vertical dampening let's set to 15. And finally, we'll add one more node. We'll add a collision push node. A collision push node will basically push the camera if the burn arm collides with a mesh. So if we add a new child pin and hook this up, we don't need to change any of the defaults here. Let's go ahead and build this. So now how do we transition from the first person camera view to the third person camera view? You notice up here there's also a transition tab. We select that. We're presented with this node here that has an add enter transition pin and an add exit transition pin. We will select the add exit transition pin, and there's a number of different options in the out toolbox for transitions as well. We will add in a camera rig transition and hook that up like so. And then for the blend option, we will drag off that pin and we will select smooth blend. So when our camera exits out of the third person perspective, it will smoothly blend into the next transition. We can also go back to our first person camera rig and then select transitions and do the same. So we'll add in an exit transition pin, drop in a camera rig transition, and then out of the blend pin, add in a smooth blend. So once it transitions out of the first person perspective, it will smoothly blend into the next transition. Let's go ahead and build both of those and save. Now to actually handle the transitions between our two perspectives here, the transitions will be handled in our evaluator. But before we do that, we'll just go back to our third person character and go to our event graph. And we'll add in a control to transition between the first person and the third person perspective. This time, so I'll right click, and this time rather than using the debug tab key, I'll just use a tab key. So we type in tab key and then select tab. The difference between the debug tab key and the tab key is that a debug tab key will not work in a packaged build of the game. But now what we're doing is we're actually providing the player with the choice to transition between a first and a third person perspective. So out of the pressed button, over in the variables, I'm going to add a new variable and I'll call this active camera rig. And I'll change this to type integer. I'll also add in a new integer variable as well, and I'll call this max camera rigs. We have two different camera rigs at the moment, but because an integer starts at index 0, we would change the max camera rigs to 1. So the number of camera rigs is actually 2, but we've got the 0 index and the 1 index. The reason why I'm adding in this max camera rigs variable is if we want to add in some additional camera rigs in the future. So for example, if we want to add in a debug third person view, which is further away from the player, we can add in additional camera rigs in the future. That for now, we'll just leave that value at a value of 1. So when the player presses the tab key, we will first check to see if the current active camera rig is equal to the max camera rigs, and then add in a branch. If our active camera rig is not currently equal to the max number of camera rigs, that means that the active camera rig is currently 0. So if it's 0, we want to get our active camera rig and we want to add 1. And the output, and we'll select clamp integer. The minimum value will be 0, and the maximum value will be our max camera rigs. And then finally, we'll use the return value of our clamp node to set the current active camera rig. But if our active camera rig is currently equal to our max camera rigs, in this case, if this variable is equal to 1, the next time we press the tab key, we want to set it back to 0. Like so. Let's highlight this, comment, change camera perspective. Now let's go back to our Camera Director evaluator. And now I'll just disconnect this pin here, and we'll right click and type in find evaluation context owner actor, and we will set the actor class to our BP underscore third person character. And with that class selected, we can now get the active camera rig. And out of our active camera rig, we will do a switch node, switch on int, and hook that up like so. We have two integer values in our active camera rig. We have the 0 and the 1, so let's add two integer values for 0 and 1. If our integer value is equal to 0, we will activate the first person camera rig. And if our integer value is the 1, we'll just duplicate this node and change this to our third person camera rig and hook that up like so. And we're almost finished with this, but if we just go back to our level and press play, currently in our first person mode, if we hit the tab key, we'll transition to our over the shoulder key. And if we press the tab key again, we'll move back to first person mode. Great, so that's how you can use the new Camera Director to change camera perspectives for your player character. Now, before we move on from this section of the tutorial, we're just going to make one final change to our setup here, and that is because hard coding the tab key into the control system is not very good practice. It's extremely inflexible. It doesn't allow the player to update key bindings, and it only allows for the keyboard type controller to be able to execute this control. So we're going to add an enhanced input action. So we'll go down to our content drawer, and we want to go into the content folder and in input, and we'll go into the actions folder, and we're going to right click, go to input, and then select input action, and we'll call this IA underscore change camera perspective. We'll double click that, and we don't need to change any of the defaults in here. It is a bool type control, so we'll leave this for now. And what we're going to do is add this input action to the input mapping context. So we need to go to IMC underscore default and double click on that. And we'll add a new mapping and select IA underscore, and then select change camera perspective. We'll expand this open. For the keyboard type controller, we will select the input and press the tab key, and that will assign the tab key as the control for our keyboard. And let's add in a new control, and let's add in one for the Xbox controller. So let's select the drop down arrow, and under gamepad, we're looking for, if we just type in thumbstick, and we're looking for this one here, gamepad right thumbstick button. So when the player presses down on the right thumbstick button, it will change the perspective. You can add in additional controls if you wish, for example, the PlayStation controller. I'll just leave this at keyboard and Xbox controller for now. Quick save. And if we go back to our BP third person character, we'll delete the hard-coded tab key, and we'll go to actions and then drag in our input action, expand the dropdown, and we will use the started execution. And then we can just collapse the rest of these. Compile and save. And let's just check that this is still working. Hit a replace the tab key, and that is changing our perspective without issues. So that's everything we need to worry about in terms of changing the camera's perspective. Now let's move on to changing our alien's skeletal mesh. So before we implement the skeletal mesh, let's optimize it a little bit. So if we go into the alien assets folder and mesh, and if we drag out the SKM skeletal mesh, we want to be able to optimize how the engine renders this mesh depending on how far away or close the player is. If we're really far away and can barely even see the alien, we don't want to be rendering every single triangle on this mesh. If we go into our wireframe mode, for example, you see that this mesh is quite dense. So we don't want to be wasting resources rendering our whole mesh if there's no need for it. So let's go back to our lit mode. Now there's two different ways that we could optimize the rendering of the mesh. There's the traditional way, which uses levels of detail or LODs. This is where the mesh will update to different levels of detail based on how far away the player is from the alien. And there's the new way in Unreal Engine, which is using Nanite to optimize the mesh at runtime. I'll show you how to use both of these. My general philosophy in terms of what we should use is that I'm fairly forward-looking in terms of the technologies that's been adopted. And Nanite is getting better and better with every release, so I will be using Nanite to optimize the rendering of the mesh, but I'll show you both methods. Let's cover levels of detail first. So if we go to our content drawer and double click on SKM_alien to open up the asset in the viewport, you'll see if we go up here, there's a button called LOD Auto. If we select that, you'll see that there's currently only one LOD to choose from, which is LOD 0, which will be the highest quality LOD. But if we go over here into our asset details panel and scroll down to where it says LOD settings, the number of LODs currently displaying is 1. If we select this and add in the number 4, press enter and then click apply changes, this will automatically generate 3 additional LODs at varying levels of complexity. It may take a little while to generate them, but once that's finished, you will now have additional LODs that have been added to our group. Just zoom in a little bit closer here, and if we change from LOD 0 to LOD 1, you may notice some slight differences. It might be easier to notice if we go into wireframe view mode. So now we're at LOD 0. If we change to LOD 1, you'll notice that the triangle count has reduced. And LOD 2 is reduced even more, and LOD 3 has reduced to an even simpler mesh. We go back to lit. It still looks pretty good, even at LOD 3. That's one way to optimize the rendering of our mesh in real time. So you can choose to keep those LODs if you wish. I am going to use Nanite instead. So what I'll do is I'll go back to LOD settings, and under number of LODs, I'll just change this back to the number 1 and select apply changes. And this will remove the generated LODs. But now let's close this asset window and go back into our level. But before we activate Nanite, we'll just show the visualization of Nanite. So we can go to the view mode setting, and then rather than lit, we will go down to Nanite visualization and select triangles. And you'll see that the environment is using Nanite throughout, except there's this black space where our character mesh is, because our character mesh is not using Nanite. Let's go back to lit mode, and we can enable Nanite by going to our content drawer and then right-clicking our skeletal mesh asset, going up to where it says Nanite and then clicking the checkbox. And just give this a moment to recompile the mesh. Now that's done, if we go back into our view mode and select Nanite visualization and triangles, you now see that our skeletal mesh is a Nanite mesh. And the further we get away from, the more optimized those triangles become. And that's all taken care of through the power of Nanite. So we go back to our view mode and go back to lit. So now let's implement this skeletal mesh. So let's go back into our content drawer and into content folder, and we'll go into the blueprints folder and then characters, and then let's open up our BP NPC alien. Go to our viewport. Let's select our character mesh, and then let's replace this with our SKM_alien. Now this does look a little bit cursed at the moment, and that is because we're using an improper animation blueprint, which is not configured for this skeletal mesh, and we're also using materials that do not belong to this character. So let's deal with the materials first. Let's go over to the materials section and click this arrow to reset to default. Now we've gotten rid of that. Now let's deal with the issue of the animation blueprint. So let's scroll to where our animation blueprint is, ABP_alien, and let's open this up. We're going to retarget this animation blueprint to our new skeletal mesh. But when we retarget an animation blueprint, what will happen is that it will not only retarget the actual animation blueprint, but it will also retarget all the animations that are used within that blueprint. Now, because we have our own animations that we'll be using, we don't need to retarget these animations inside the blueprint. So what we can do is we can actually get rid of some of these. And we're not actually going to be needing the states in this main states graph. So we can actually, so we'll go ahead and delete that, and we'll delete the main states cache as well, which means we'll need to replace the cache we were using over here. So we'll replace it with the Locomotion cache instead. So let's right click and type in Locomotion and select use cache post Locomotion. And we'll just replace these like so. Delete that one, and we'll copy and paste and replace this one as well. And then just compile. Now let's go into our Locomotion state machine, and we're just going to remove the animations from the output animation pose. So let's get rid of that, and we'll go to the walk run state as well, and we'll just delete the blend space, compile and save. And now that we've removed all those animations and saved our animation blueprint, we can go ahead now and retarget the animation blueprint. So go to your content drawer and then right click on ABP_alien, and we will select retarget animations. The source skeletal mesh will be SKM Quinn Simple. The target mesh we want to be our new SKM_alien. And then in the assets drawer down here, we just want to select ABP_alien. We'll save this new animation blueprint where our current animations are for this asset. So that's in the alien assets folder. And then just select the anims folder and then select export. Now, we don't need to include the referenced assets, and we're not actually retargeting any additive animation, so we can uncheck that as well and then just select export. Now we've got an animation blueprint that is set to our custom skeletal mesh, so let's go ahead and save that. Now you'll notice a new problem when we open up the animation blueprint, and that's because we have an issue with the control rig that we're currently using. And that's because if we go to the anim graph, which is over here, right here, we're using a control rig which is specifically designed for the UE5 mannequin. Now, in order to fix this, what we can do is we can go to where this control rig is actually saved. So if we select the control rig and then under the details panel, we should find the, here we go, the control rig class. We just browse to that asset, and this will take us to the control rig that is being used. We will copy this asset into the alien assets anim folder. So the under alien assets and anims, we will drag and drop that onto that folder and then select copy here. Now let's go back to our folder and we will open this up. Now this control rig is specifically designed for the bone hierarchy of the UE5 mannequin. To change this to our custom mesh, what we can do is under this rig hierarchy option here, we will first select the root, scroll all the way down, and then shift select the last item here. So we've selected all of the bones and then just simply delete. And now after we've deleted those bones, it's given us this option to import a new hierarchy. So if we select that button and then from the mesh dropdown, select our custom mesh and then select OK, we've now imported the new hierarchy from our custom mesh. It hasn't actually updated the preview yet. So if we go over to the preview settings tab and under preview mesh, we change that to our skm_alien. That will update the preview mesh. We're not quite finished just yet. Now we just need to make sure that there's no issues with the bone names. This one seems to be fine. They've both got the same name for the IK foot bones. Let's scroll down a little bit, and here we've got a bit of a conflict. So this is meant to be the IK foot L. It's slightly different with the capitalization. So let's select this drop down and type in IK, and we'll select the IK foot L. That replaces it with the right naming structure. And we'll do the same thing here, IK, and select IK foot R. This one's fine. And we've got another couple of errors down here. Same thing. So you'll select this and type in IK underscore, and we'll select IK foot L. And same thing here, IK, and then select IK foot R. And if we save that, now what this control rig is essentially doing is it's making it so that the feet will conform to the surface that the character is walking on. This is particularly useful when the surface level changes. For example, when walking up and down stairs, we want the feet to conform with how our environment actually changes. So now let's go back to our animation blueprint. And just a quick example of how this works is if we just remove that control rig for a moment and then select compile, you'll notice that our mesh is floating slightly above the ground here. But if we bring our control rig back up and hook this back up, and now we'll just go into our control rig and update the class. So under control rig class, we'll change this to I didn't actually change the name of our new control rig. So if we go back to where, here we are here. So if we change this to CR underscore alien underscore foot IK, and so that, if we go back to our control rig in our animation blueprint, we can now select this and type in CR underscore, and we'll select the alien control rig. And now when we compile, the mesh has moved back to conform with the environment. So now we've got no more errors, and that's great. Now we can add our own animations. So the first animation that we'll add is just a very simple one, and that is the idle animation. So let's go into our Locomotion state machining and then double click the idle state. Now let's go to our content drawer, and in the idle folder for our animations, we'll select the alien idle loop, drag that onto the graph there, and we will go into our details panel and make sure that loop animation is true, and then hook that up and compile. And now we are running the idle loop animation for our alien. Now we've actually got two animation blueprints with the same name now. So let's go back to where the previous one was that we retargeted. Let's go, which is, I believe, in the third person folder. No. To what we can filter. If we select this filter option here, let's select under all filters, animation, animation blueprint. Okay, here we go here. So this is the old one, ABP underscore alien. Let's rename this to just add the word old at the end there. Okay, now let's deactivate that filter, and we'll go back to our NPC character class. And with the mesh selected, let's add our new animation blueprint and then compile. Now the collision capsule as it is at the moment is probably not going to work very well with our mesh. So let's maybe change this a little bit. Maybe let's move the mesh backwards slightly just to conform more with the collision capsule. And let's maybe actually increase the collision capsule radius. So instead of 35, let's maybe increase that to 45, because it is a bit of a bigger mesh that we're using now. Okay, that looks pretty good, and we'll compile that. So now that we've got our character blueprint set up, let's just get rid of the skeletal mesh from the world here, and I'll drop in our character blueprint. So at the moment, we've just got the idle animation on loop. So let's add in our locomotion animation. And to do that, we're going to use a blend space. So let's go back up to our content folder and into our alien assets, and in the anims folder. In here, we'll create a blend space. So we'll go right click and then animation and select blend space. We will select the sk_alien skeleton and call this bs_alien. Actually, we'll call it bs_alien_locomotion. And we'll go ahead and open that up. Now, if you've never used a blend space before, it's basically a way to blend in between certain animations depending on the specified axes. So for example, if we're moving the character's speed from an idle position, which is a speed of 0, into a walking speed, we want to smoothly blend from the idle animation into that walking animation. In the blend space, we have two axes here. Over in the axis settings, we have the horizontal axis and the vertical axis. For our horizontal axis, we will assign this as the direction. And for our vertical axis, we will assign this as the character's speed. So let's go into the horizontal axis first. And for the name of this, we will change this to direction. And we can assign a minimum axis value and a maximum axis value. Right now we have 0 all the way over here at the left and 100 all the way over here at the right. We're going to change this to a minimum value of -180 and a maximum value of 180. So this will represent the direction of 0 degrees, which will be directly forwards, all the way around to -180 degrees, which will be facing exactly backwards, and +180 degrees will also be facing backwards as well. So +180 and -180 will be the same direction as each other. And everything in between here will depend on the way that the character turns towards that backwards position. Moving from 0 to 180, the character will be turning right. Moving from 0 to -180, the character will be turning left. Now, the animations that we have are 8 directional animations. So we have walk forwards, walk left forwards, left backwards, walk right backwards, and right forwards. So in our horizontal axes, we have a grid divisions 4. We're going to change this to 8. And for the time being, we will also snap to grid. So if, for example, we were to drag an animation onto our graph, you'll see that it is snapping in the horizontal axes grid divisions. Now let's move on to the vertical axis. Let's expand this option. And the name for this axis we will call speed. And the minimum axis value will be 0, so not moving at all. And the maximum value, let's set to 600 for now. We'll leave the grid divisions at 4, and we will have snap to grid selected for now as well. So on the very bottom of this axis will be the speed of 0, and at the very top will be a speed of 600. So first things first, let's add in our alien idle loop animation. In the asset browser over here, you should see the alien idle loop animation. We're going to drag this into the bottom position here at direction 0 and speed 0, but we're also going to add this to each point at the bottom, like so. There we go. Now let's do our walking animations. So they should be at the bottom here. So alien walk forwards. So you'll recall that the 0 direction is forwards, and let's bring our alien walk F onto the center here. Now, if you hold down on the control key while moving your mouse around, you can preview the transitions between our idle animation. And as the speed increases, it will smoothly blend into the walking forwards animation. If you don't see the preview, make sure that the animation is actually playing. Now let's add in our alien walk left forward, so LF. We will add this here. Next, we'll add in the alien walk L. Then alien walk LB for left backwards. And then finally, alien walk backwards. Now let's do our walking right. So we'll go to alien walk right forwards. then alien walk right, alien walk right backwards, and then finally again, because positive 180 is the same direction as negative 180, going to add the walk backwards here as well. So right forwards, right strafing, right backwards, and backwards. Now finally, let's add in our running animations. So if we scroll up a little bit, we'll see the different running animations. Our 0 degrees direction will be running forwards. So let's drag in our running forwards to the top there. Our run left forwards, then run left backwards, and then finally run, let's see, run backwards. For our right animations, so we'll do right forwards, then right backwards, and then finally backwards again. Now we can preview this, so we're walking forwards to running forwards, running left forwards, running left backwards, and then running backwards. So as the character's speed and direction updates in real time, it will smoothly blend between these animations. There's another option over here called smoothing time. So according to the description here, smoothing time is used to move smoothly across the blend space from the current parameters to the target parameters. So at the moment, if we preview our animation, you'll see that this little X is following along exactly where our mouse is. But if we were to add in a smoothing time of 0.5 to our horizontal axes and 0.5 to our vertical axes. And now if we hold down the control key, you'll see that there is a slight delay with how the X is smoothly blending from the current parameters into the target parameters. There are different smoothing types. We'll leave this at spring damper for now, and we'll go ahead and save that. Now let's implement this blend space into our animation blueprint. So let's go back to our content drawer and go back to the anims folder and make sure our animation blueprint is open. And from our anim graph, if we go into our Locomotion state machine and we'll go into our walk and run state, this is where we will use the blend space. So if we go to a content drawer and drag in our blend space and hook this up like so. Now we're going to make a couple of changes here because the variables that we used for the mannequin will be slightly different than what we use for the alien. So we'll just remove these from the graph and create our own. Let's go back to the event graph. And I'm going to shift some of these down a little bit. Move these down here. We'll add a new pin to our sequence, and I'll just move these pins down like so. We'll create a new execution out of the index 1. And we're going to create our own speed and direction variables. So to do that, we'll right click on the graph and select try get pawn owner. To get our speed is fairly simple. We'll just drag out of the return pin and type in get velocity. And then out of the return value again, we'll type in vector length. Okay, and we want vector length xy. The difference between the vector length and the vector length xy is that the vector length xy doesn't take into account the z-axis. So we're only really concerned about how fast we're moving on the ground and not how fast we're moving up or down. So we'll get the vector length xy. And then we will promote this return value to a variable. And let's call this variable move speed. Compile that and we'll hook up the execution. So that takes care of the move speed. Now we'll just get the direction as well. So to do that, out of the try get pawn owner return value, we will get actor rotation. Then out of the return value, we will do calculate direction. And for the calculate direction, we need the base rotation and the velocity. So we will hook up the return value from our velocity as well. And this return value we will promote to a variable and call this move direction, and hook this up to the end of the execution like so. And I'll comment this set move direction and speed. Save that. And now if we go back to our walk and run state, we can drag on our move speed variable and drop that onto the speed input and our move direction, and then compile. So we're almost ready to test this out now. So we'll just go back to our level. But before we are able to test this, we need to add a nav mesh to our level. And in a future lesson, I'll cover a more in-depth tutorial on using nav mesh and nav mesh modifiers. But for now, we will just add in a simple nav mesh volume. So from the place actors panel, we'll go to the volume section, and then we will add in a nav mesh bounds volume. And if we press the Alt J to see the whole overview, let's press the W key to move this into roughly the center of our map. Then press the R key, and we will expand this to cover the whole section. And we'll press Alt K to go into side view mode, and we'll expand this out again to cover the entire section. Then press Alt G to return to the game view mode. And now if we press the P key, you'll see all the navigable areas in which our NPC can navigate. As I said, in a future video, I will go through a more in-depth usage of the nav mesh, how to block off certain areas from navigation, how to link different areas of navigation that aren't linked on the map. But for now, this will do fine. Let's go ahead and test this now. I'll just press the P key to remove that view, and let's test this out. Press Alt P. Character is currently idle, and it should start moving once it sees us. And now your character is following us. Now, there seems to be a bit of jittering with our first-person camera here. Okay, so after doing a little bit of investigation, I've determined that the camera shaking seems to be caused from the offset node here, specifically the translation offset on the x-axis. It seems that the further away that our x-axis gets from 0, for example, let's bump this up to 300. So this will be 300 units in front of our forward of our mesh. So if we press play and walk backwards here, you'll see that this shaking is much more noticeable when walking backwards, which is a particularly strange issue, and I'm assuming it's a bug, because if we set this to 0 and now press play, you'll notice that that shaking has gone. But of course, this is not a desirable viewpoint for our player character. So what we could do is just make an adjustment to our mesh. So in order to fix this, what we might do is set the location of our mesh backwards by -30 units on the x-axis. And if we press play, we now no longer have those shaking issues. Okay. And our NPC is also working. Now, one final thing we're going to do with our animation blend space before we finish up today is we're just going to clean the foot sliding. Because if we press play, and remember we've added some previous debug code to slow down time by pressing the left bracket key, let's slow down time to -2.25. And I'm going to walk in front of the, and you'll notice that the alien's feet are sliding across the floor. And that's because the animations are not aligning with the optimal speed of the character. Now there's two different ways you could fix this. There would be the manual way. So if we go to the animation blueprint, you could manually try to align these animations to the correct speed, but that is very time consuming. So there is an option to automatically do this in our blend space. First of all, for the speed axis, what we're going to do is we're going to disable the snap to grid. So now we can freely move these animations along any speed on the graph. If we go over to our asset details, scroll down under our axes, there's a section here called analysis. And what we can do is we can get Unreal Engine to analyze the foot movements and determine the best speed for that animation. We can analyze either the horizontal or the vertical axis. Because our vertical axis is the speed option, this is the one that we want to analyze. So for our vertical axis function, we can select this, and we want to select Locomotion, and this will analyze Locomotion across 27 samples. So the 27 samples that have been added to our graph, we can expand this option and expand the analysis properties. Now what we need to do is we need to assign the bone sockets that Unreal Engine will analyze. Now the bones that we want to analyze aren't actually the foot bones. Pause this animation, you'll see that it's not actually the foot bone that is making contact with the floor. It's actually the ball of the foot here. So if we search for ball, see the ball L and ball R are the bones that are actually making contact with the floor. So these are the bones that we will analyze. We'll go back to our asset details. And for our bone socket 1, we will search for ball and select ball L. And bone socket 2, and search for ball and select ball R. Character facing axis is Y direction. And so this should conform with the direction of this gizmo down here. The character is facing the Y direction. And character up axis is the Z axis. So we don't need to change either of these. And now what we can do is press this button here, which will analyze all the samples. This may take a moment, but once that's done, you'll see that our animations have moved, and they've moved to the most optimal speed for that particular animation. But there is a bit of a problem here because some of these animations quite clearly seem to be analyzed at slightly different speeds to each other. So this means that, for example, if we were at speed 466 and then we move slightly faster, you'll notice that this animation is now not blending correctly. So the way that I tend to use the analyze function is I try to use the analyze function to get the best approximate and then clean up the animation so they're all on the same grid. So what we can actually do is for our vertical grid, we've got 4 grid divisions currently. Let's increase this to 12 and then re-enable snap to grid. And now let's just clean this up a little bit. So what I'm doing here is just moving these so that they better, cleaning this up a little bit so that it can better transition in between animations. And let's have a look at the speed here. So the speed here is 500. And I believe that that's actually our character's running speed assigned in its character blueprint. So let's maybe go to content draw and find our alien AI character. So it's in blueprints, characters, NPC alien. And there was a movement speed structure that we created. Let's expand the default values here. And yes, the attack speed is set to 500. So now if we go ahead and press play again, and let's slow speed down to 0.25 again, let's take a look to see if our foot sliding has been improved. So there is still some minor foot sliding. Just because we've manually repositioned the animations on our blend space. This isn't going to be very noticeable. What we could do is if we wanted to refine this even further, we could either slow down our character's max movement speed to be aligned with the desired movement speed of our animation, or we could slightly increase the speed of our animation itself. But I think this is perfectly fine for now. If we want to do some minor refinements in the future, we can. But for now, if we play this at regular game speed, it's hardly noticeable. It seems to work pretty well. So I think that's perfectly fine for now. Finally, just before we finish up, let's set our alien's default motivation back to search. So under Blueprints, AI, Alien, open up the state tree. And let's change the default motivation parameter to search. So when we play our game, the alien starts in a search behavior state. So there we have it. In this video lesson, we've added in a brand new gameplay environment. We've changed our player's perspective to first person, and we've added in a new character mesh with brand new animations. So now we're ready to start diving into more advanced topics in the upcoming videos. So I will see you in the next video. The project files from this lesson are available to download from Gumroad completely for free. However, if you would like to support the ongoing work that I do, please consider making a donation either via the Gumroad page or via the Buy Me a Coffee page linked in the video description.